DPPs are finished and let's solve some questions. Actually, I am changing DBP into questions. I am solving question by question, so we better call it as question and solve those. The question is this is the 14th question I am uploading in this channel. The 14th question is 0.6 grams of urea. Do everybody know urea's symbol or formula? Urea's formula. It is NH2CONH2, right? It's written as NH2CONH2. So it was given that 0.6 grams of this urea on strong heating with NaOH evolves NH3. This liberated NH3 will combine completely with which of the following HCl solution? That means here NH3 when 0.6 grams of urea on strong heating with 0 NaOH, it gives us NH3. The product is NH3. This NH3 will combine completely with which of the following HCl solutions? They gave some in the options. They gave some of the HCl solutions with different volume and different normality. So we should find out this produced NH3 will completely mix with which one, which will completely combine with which of the following HCl solutions. So to do this, first let's clean it. So now, yes. So now we should see NH2 CO NH2 plus NaOH. This is urea and this is sodium hydroxide, which on strong heating results as Na2CO3 and our required product ammonia. Now let's balance this reaction. Here nitrogens present are 2. Here one nitrogen only present, so 2. Let's place 2 here. Hydrogen here totally 2 plus 2 4 plus 1 5. Here 6 are there. 4 plus 1 5. Here sorry, here 2 sodiums are there, so we can see 2. So now totally 6 hydrogens were there, and in right hand side also 6 hydrogens were present, so these are balanced. Nitrogen balanced, hydrogen balanced, carbon is also balanced because only single element is present, single carbon atom. Oxygen, about oxygen, these are here 2, here 1, totally 3. Yes, here 3 oxygens are also sufficient. Yes, everything is balanced now. Yes, everything is balanced now. Let's clean it up. Yes, now this is the reaction. Now if we clearly observe, this is urea, right? This is of 0.6 grams of urea was heated. First, let us know how many number of moles of urea is participating in this reaction. Here if we see, here 1 mole of urea reacts with sodium hydroxide, produces sodium carbonate, and 1 mole of ammonia, right? Here for 1 mole of urea, it produces 1 mole of, sorry, here 2, right? I cleared balanced equation, right? I'm sorry. I'll write it again. Let's rewrite the balanced equation. Write it back. NH2 CO NH2 plus NaOH on strong heating. It results as Na2CO3 plus NH3, which is the required product. Here for balancing, two nitrogens are present, so here two sodiums are present, so here two. So now it's completely balanced, I think. Yes, 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 completely balanced. This is the reaction. So let's now discuss. Here 1 mole of NH2, sorry, NH2CO NH2, which is urea, gives us results as 2 moles of NH3, 2 moles of ammonia. So let's calculate about 0.6 grams, because here it is taken about 0.6 grams. Now number of moles of this is double, this is half the number of moles of NH3 ammonia. So let's calculate the number of moles of urea. Now number of moles of urea comes out to be given mass by 0.6 by molecular weight. Molecular weight results as in 2 nitrogens, which is 2 into 14 plus 1 carbon 12 plus 1 oxygen 16 plus 4 hydrogens, 4 into 1, which is 4. Now if we calculate this, 28 plus 28 plus 4, which is also 60, which here which results as 0.01, right? Yes, yes, it's 0.01 moles. So 0.01 moles of urea is reacting with some NaOH, some moles of some X moles of NaOH. It results in double this. Ammonia's number of moles is double this. So if 1 mole is reacting, here 2 moles are produced. So here 0.01 moles are reacting. So here 0.02 moles of NH3 will be the product, right? Yes. Now if we carefully observe here, liberated NH3 will combine completely with which of the following solution? Which of the following HCl solution? So here ammonia is base, right? And HCl is acid. So how many moles? 0.02 moles of NH3, right? That means if an base should combine with acid, here HCl, it should be neutralized, right? This is called neutralized reaction, right? Neutralization, right? If a base is mixing with, is combining with acid, here ammonia is base, right? And HCl is acid, so it should be neutralization reaction. So in case of neutralization reaction, number of moles of acid should be equal to number of moles of base. This should be learned by you. The principle is number of moles of acid is equal to number of moles of base in terms and conditions applied in neutralization reaction. In neutralization reaction, that is when acid is reacting with base, combining with base, number of moles of acid with base will be equal to number of moles of acid. So here we can define that 0.02 moles of HCl is present. right? So now we should find out which quantity of NH3 or which normality of NH3 of HCl will combine with this liberated NH3, right? So to do this, first of all, you should know about normality. Before normality, you should also know X factor, which is acidity or this L issue, right? Now, basicity. Basicity is nothing but number of H plus ions for number of liberated H plus ions, which so number of H plus ions that can be released from a compound, dissociate number of H plus ions, dissociable H plus ions that will be released is called basicity. So for suppose here ammonia is there, right? Not ammonia. For ammonia, acidity will be there because it's a base. So here acid is HCl, right? Here one H plus ions can be dissociated, right? So here number of H plus ions, dissociatable H plus ions which will be dissociated is 1. So HCl's basicity is 1. I hope everybody understood. And in case of bases like NH3, here acidity will be there, right? In case of acidity, number of OH minus ions. Yes, everybody understood. Now this basicity or acid and acidity are thought for this. You will understand now why I am teaching this actually. Now normality is equal to molarity into X factor. This X factor is called acidity for bases and basicity for acids. Understood? X factor is nothing but if it is in case of acids it is basicity, in case of bases it is acidity. So in case of now we are taking for HCl, right? So it's basicity obviously. Here basicity of HCl is 1. So we can remove X factor here. Okay. Now normality is equal to molarity. Hope you understand. Now molarity formula everybody knows, right? Number of moles of by volume in liters, right? But in case of number of moles is given by given mass into given mass by molar mass. So number of moles comes out to be given mass by molar mass by volume, which comes out to be 1 by volume in liters. Here if we solve further, we will be getting given mass by molar mass into 1000 by V volume in milliliters. So wait a sec. Yes. Now here molarity is number of moles upon volume in liters. But if it is in milliliters, it is volume by 1000, right? Hope you understand. So now we should find out which NH3, which amount of HCl is required to combine with this liberated NH3. The options were, first option was 100 ml of 0.2 NHCl. So here we should find out that number of moles, whether the number of moles are coming as 0.02 or not. If number of moles were 0.02, then it is combining with NH3, or else it was not combining. So we should check all the options, either one, if not one, you should go with two, if not two, you should go with three. You should trial and you should apply trial and error method, and you should check all of these options, right? So first option, let's check it. How to check? First, here normality is equal to molarity, because normality is given as molarity into X factor. Here X factor is basicity of HCl, which is 1. So normality becomes molarity. So now normality, it is calculated as 0.2 number of into, here volume is 100 milliliters, right? Then if 100 milliliters, 100 by 1000, right? Which comes out to be 10, which comes out to be 0.02. Yes, this is the perfect answer. You can also go with other three options, but they will not result in 0.02, right? So this is the correct answer we have obtained. Hope everyone understood it clearly. Okay.